Hi and welcome to this Leaving Cert Applied Maths video, and today we're going to look at activity networks. So as part of this video, we're going to look at what an activity network is and how to read it. We're going to look at how to build and use a precedence table. We're going to look at how to calculate early and late times, how to identify critical activities and in turn the critical path. We're going to discuss dummy activities, what they are and how we handle them in our calculations. And we're going to look at how to draw and interpret our Gantt charts or Cascade charts and how to calculate floats and understand project flexibility. So first off, what is an activity network? So an activity network is a graph that shows the activity needed and in what order to complete a project. So some activities will depend on others being completed first. Some activities can occur at the same time. The arcs or edges of the graph represent the activities, and activities are denoted by the letters A, B, C, D, etc. Arrows are drawn on the arcs to show the order in which the project progresses. So the nodes and vertices of the graph represent events within the project. Events are labeled with numbers, generally increasing in the direction of the project. The event at the start of the project is called the source node, and the event at the end is called the sink node. One really important difference when we're working with activity networks compared to our normal graphs is it's really all about the edges. The nodes aren't really going to come into play. Our focus is on what's happening on that arrow. That is the activity. That is the important piece. We really, really need to focus on that as opposed to when we're working with our other networks where we're working with Dijkstra's, where we're working with crucicles, working with prims, even where we're working with Bellmans, our focus is more so on the nodes. Here, our focus has to be fully on the activities which are on the arcs. So what do we mean by early and late times? So we're going to be filling in an activity network and we're going to be calculating the time it takes to complete a project. So every project will have an early and a late time. The early time of an event is the earliest possible time at which all preceding events are finished. So that's the earliest it could possibly start. And the bottom is the late time, which is the latest time that an event can start without delaying the project. So it's really important that we understand how to complete these boxes. Once you get into the swing of this is an absolutely lovely question. Our source node, which if you remember is at the start, will always be 0, 0, and the sink node will always be TT, where T is the minimum total time for the project. And this time is called the critical time. This is really, really important because we're going to calculate T once, and then you have to be aware that it's filled in a second time. So to complete the activity network, we're first going to work forward from the source to sink to complete the early time. And once you find the early time, you're going to fill that in as the late time for the sink. So remember, the sink has the same early and late time. Once you've that filled in, we work backwards from sink to source, completing the late times. And when you're filling them in, we have to remember these two really important rules. We always take the biggest early time and the smallest late time. That's so important. So the biggest early time and the smallest late time. So what do we mean by float? So the total float of an activity is the amount of time that its start may be delayed without delaying the whole project. So to calculate the float, it's going to look something like this. So it's the latest finishing time minus the earliest start time minus the duration of that activity. So in terms of when we're looking at the network, we have to look at those three elements. So the latest finishing time, the earliest start time, and the duration. A critical activity has a float of 0. And we'll talk a little bit more about these as we go through our actual questions. It's easier to see and for me to point out the things that you really should be taking care of, the things that students often get wrong in exams. So a critical activity has a total float of 0. That means it has no wiggle room. So An activity like that is critical because if there's a delay in it, it will delay the whole project. And then a critical path is a continuous path from source to sink, which joins only critical activities. So any delay in an activity on the critical path will result in a delay in the whole project. So let's take a look at question 10 from the 2023 ordinary level paper. The diagram below shows the scheduling network that an account company uses for processing an account. The edges of the network represents the activities that the workers need to carry out when processing an account and are labeled with the letters A to L. The letters used to label the edges should not be taken as representing the order in which the activities happen. The time in minutes to complete each of the activities is shown in brackets. The node of the networks represent events or points in time during which the processing of an account. The source node is the time when the processing begins and the sink node is the time when the processing ends. Part 1. Calculate the early time and late time for each event. Complete the diagram below by writing the early time in the upper box and the late time in the lower box at the node representing each event. Just making it a little bit bigger for me to be able to work with it. So the first thing we do is we start with our source node and we put in 0, 0. We then going to work with activity A. So activity A will take 52. I'm not sure, is that, oh, that must be, I don't know, is it days or hours, but 52. So this is going to be put in the top there. The reason it goes straight in is because there's no other option. For B, we have 40. So then if we come along to C, so we're coming along and we add on 62, we have 52 plus 62, so that is 114. Now, this node here is interesting. So the timing here we have to be careful with because there are two activities that feed into it. We have E and we have F. So we need to look at both of those times and decide which one we're going to take. So if we go with activity E, that will give us 77 and the other one will give us 88. 88. So we have 77 and 88. And the rule is we always take the biggest early time. So that means we're going to take 88 in here. So it's really, really important that we remember that rule and our focus is on any node where there are multiple arrows feeding into it. So not all nodes will be affected. So the next one I'm going to look at is activity D. That's 100. So it's going to get us to 140. So the next node I'm going to look at is this one here. And again, there's two options feeding into it. So my first option is 117 added to the 114. That's 231. And the other one I have, so I have 231. I have 88 plus 66, which is 154. So we're going to take the bigger one, which is 231. So that's going to go in here. So we always take the biggest early time. So next we're going to look at this node here. Again, there's two ways feeding into it. We have 88 plus 85, which is 173. And then I have 140 plus 96, which is 236, which is bigger, and that's the one we're going to keep. So 236. So we're nearly at the sink node. Well, we are at the sink node. We're nearly finished our first pass, so our forward pass. So we have 231 plus activity L, which is 126. That's 357. Or 359. So 359 with activity K is bigger. So we're going to keep that. So that's 359. So we're going to put 359 directly underneath it. As soon as you get your time in the sink node, it's going to be the same early and late time. So now what we're going to do a backwards pass. Now, backwards passes basically means we're going to work back like this and say, okay, focusing on the bottom number, we have 359 minus 126, and that gives us 233. So we only had one, I say arrow into it, but coming out of it because we're working backwards. And for K, we're going to do 359 minus 123, and that gives us 236. So the next one I'm going to work with is H. So that's 233 minus 117, and that gives us 116. And then we can also work back here for J. So that's 236 minus 96, which gives us 140. So if we take a look at this node now, there are two arrows that left it, so we have two options. So the first option is 233 minus 66, which is 167. And then 236 minus 85, which is 151. So because we're working with the late times, we want the smallest possible late time. So that's going to be 151. So now we have a few more nodes left. So let's look at this one. Again, there's two options. The first option is 151 minus 48, which gives us 103. The next one with going backwards on D is 140 minus 100, and that's going to actually give us 100 and, sorry, that's just going to give us 40. So then we can look at this node. And again, it has two arrows coming out of it. So our options are 116 minus 62, which is 54, or 151 minus 25, which is 126. So our better option there is the first one, which is 54. Again, we're constantly looking for the smallest late time. So that's 54. And then just double check coming back to the source node. It's already filled in, but it's good to check. So there are two options. One will be 54 minus 52, which will leave us 2, and the other is 40 minus 40, which gives us 0. So that is all completed. So what you'll notice are there's some nodes where the early and late times are the same. So for example, here, that's the same, that's the same, this is the same, and this is the same. What that is indicating to us is that there's some activity attached to that node that is going to be a critical activity. So when the early and late times are different, what that means is there's wiggle room. We have what we call our float. But just be careful, focusing on these nodes alone will not get you critical activities, and we'll see some examples of those. So our critical activities, remember, our focus is not on the nodes, our focus is on the edges. So we are going to keep looking at those particular nodes to help us, but for the edges, we're looking at this one here. How we know this is critical is that it starts at time 0, it takes 40, and the latest time it can be is 40. So that all is giving us a critical activity there. Then for D, it starts at 40, goes on for 100, ends at 140, so that's critical. We then have 140 plus 96, that's going to give me my 236, which is critical. And then finally, 236 plus 123 gives me 359. So here we have 4 critical activities, that's B, D, J, and K. The rest of the activities will all have a float. It's not as straightforward as just working with the nodes, so please be careful. So part 2 here asks us to write down the critical path for the network. So you've done the hard work on the diagram, so we can just look to see which of our activities are critical, and we can see highlighted in blue that critical path. So the critical activities are B, D, J, K, and they do make a path. So B to D to J to K. So that's our critical path for the network. If the workers begin to process an account at 9:30 a.m., calculate the earliest time when the work could be completed. So we have 359 minutes for completion. Let's divide that by 60 just to give us what it is in hours. And that gives us 5 hours and 59 minutes. We start at 9:30 a.m. So we're going to add from 9:30 5 hours and 59 minutes, which is, if it helps, it's just going to be a little under 6 hours. And that gets us to 15:29 if you want to do it that way, or 3:29 p.m. Both absolutely fine. Calculate the float in minutes for I. So when we're calculating the float, a little issue the students run into is they just focus on the early late times at the end. The calculation is the latest late time minus the earliest early time, or the earliest start time minus the duration. So this is going to be 233, so the latest finishing time, minus 88, the earliest start time, minus 66, the duration, and that gives us 79 minutes. So just be really careful. Make sure you're very clear on that float. It can be a nice kind of quick way to check if an activity could be critical if the early and late times for the finishing is the same, but it's not enough to calculate float. So just be so careful. So exactly 1 hour after processing of an account has begun, the supervisor checks the work, state which activity or activities must be happening at this time. So 1 hour, we're talking 60 minutes. So 1 hour, 60 minutes. So if we then have a look at our graph and say, well, what could be happening in 60 minutes? So think about what is starting just before 1 hour. So C here is a valid possibility because it starts at either 52 or 54. So the earliest start time is going to be 52. E is the same. Okay, it's a possibility, and I'm literally saying this, it is a possibility. F is a possibility because it starts at 40 and going on for 48. And then D is a possibility. So there are 4 possible things that could be happening within an hour. So what we need to look at is to understand for each of them, is it possible that it has been delayed enough that it hasn't started? So C takes 62 minutes. Let's actually work out our flow for each. That's probably going to be the easiest way to kind of visualize this. So our flow for C is 116 minus 52 minus 62. So when we do that, we get 116 minus 52 minus 62, and that gives us 2. So it only has a float of 2. So it can't really be delayed much more. So C must be happening. Okay, so the next one, let's look at E. So our float for E is going to be 151 minus 52 minus 25. So 151 minus 52 minus 25, and that gives us 74. Now that is an issue because although it's saying that E should be starting at 52, 54, there's a 74-minute window that it doesn't have to work. So it may be happening, okay? So it may be happening. It doesn't have to be happening within an hour. It may be happening. So then if we look at F, that is 151 minus 40 minus 48. So 151 minus 88 gives us 63. Again, same issue. It has too much time, so this may be happening, but it does not have to be happening. And then for D, we have 140 minus 40 minus 100, which is 0. It is critical, so this must be happening. So the question asked us which activities must be happening, and the answers are C and D. E and F could or may be happening, but they do not have to be happening within an hour. So quite a tricky question to do when we're working just off our graph. So for a particular account, activity F takes twice as long as usual. Does it result in a delay in processing the account? So for the good news is we've already worked out the float. So F has a float of 63. The duration is 48. So if we could do the duration again, yeah, absolutely, it'll be fine. So if you wanted to look, it will be 151 minus our 40 minus, instead of 48, it will be 96 because it's doubled. And that would leave 15, which still leaves time. So there's two different ways you can think about it. Does it cause a delay? No. Make sure you answer the question. So either you look at the float of 63 versus its duration, or you calculate a new float for it. So this is question 10 from the 2024 higher level paper. A diagram below shows the scheduling network for manufacturing a car. The edges of the network represent the activities that have been completed as part of the overall manufacture of the car and are labeled with the letters A to L. The duration in weeks of each activity is represented by the number in brackets. The unlabeled edges, shown with dashed lines, do not represent real activities, but they help explain the order in which activities must happen. The letters used to label the edges should not be taken as representing the order in which the activity should happen. The nodes of the network represent events or points in time during the project. The source node is the time when the project begins, and the sink node is the time when the project ends. Okay, so first of all, let's have a little chat about those dashed lines. So these are called dummy activities. So a dummy activity is an activity that's not real. So it has a weight of 0. So they're not given letters because they're not real activities. Their only purpose is to show what happens first, which activities have to be connected. And the reason that they exist is sometimes we have one activity that depends on a previous one, but then another that depends on two, and we can't connect them properly because it would throw something out of order. So one activity might depend on activity A, and then a second activity depends on activity A and B. So it's trying to use that dummy to connect B in there. So let's start filling in our early and late times, really thinking about these dummy activities and how they're going to impact on us. So the first thing we're going to do our early times. Our early times, we're always picking the biggest early times. So let's start with our source node. So we start with our 0. We then have 3, 5, and 2. So they're all very straightforward. What I'm looking at is how many activities feed in. So all of these just have 1. So that's really straightforward. Now, here we have 2 activities feeding in. So our options are 3 plus 1, which gives us 4, okay? Or if we go with the dotted line, this 5 could be pulled forward. And we always want the biggest number, so we end up putting a 5 in there. So just be very clear about how many activities are feeding in. So then if we want to look at, we'll look at this one next. So I have actually 2 activities feeding in here. I have the dummy activity, which is 5, or I have 5 plus 7. So that's going to give us, and I actually have a third one, which is 2. So I have 5, I have 12, or I have 2. So we're going to put a 12 in there. So it's really important that you're spotting all the activities that feed in. We then here have 2 activities feeding in. I have a 12 or I have a 6. So I'm going to go with the bigger of those two numbers, which means I have a 12. So those dummy activities, all very complicated, just really need to keep an eye on it. So our next one is this has 3 feeding in it. I actually can't fill that out yet because I'll need to know this box before I can do that. So just be careful not to go too fast in your order. Here I have 3 filling in, but again, I'll need this one because it feeds through. So the next one I'm actually going to fill in is here. There's only one activity feeding it in, which makes it nice and straightforward. That means I have to put a 15 here. Then when I work out, we'll go for this one here. So I have 1, 2, 3 feeding in. So my options are 15 from the dummy, or 18 from J, or 17 from I. And we're going to put in the biggest of those, which is 18. And then here we have 3. We can now fill that in. If we're going from G, I have 8. H, I have 16. And L, I have 19. So 19 is the biggest number of those. And finally, our last node, this is our sync node, and we have 2 options feeding in here. We have 21 if we're coming through M, or we have 19. So we pick the bigger one, and that is 21. So that is all my early times completed. Then I complete my sync node. So remember, this is my sync node. This is also 21. Okay, they will always match. So as soon as you get the total of your early times here in the sync node, you put it at the bottom. Now we work backwards. So I'm just going to change my color slightly so we can see what's going on. So the first one I'm going to do is this one here. So I only have 1 feeding back. So we're looking at feeding backwards, or another way to think of it is coming out of that node. So going backwards, this gives me 19. Okay, so then if I look at the next node, this has only 1 feeding backwards into it, which is going to give me 18. And then this node here has 2 feeding into it. So from the dummy, we have 18. And from N, we have 17. We always pick the earliest late time, so the smallest one. So we have 18 or 17, so we're picking 17. Okay. So then I'm going to look at this node here. I have 2 feeding backwards into it. Through J, it's going to give me 12. Through K, it's going to give me 14. I always want the smallest. So there is my 12. The next one I'm going to look at this one here. It has 2 coming back into it. I can't do that one until I've worked the one below it, which means this one has 1, 2, 3 coming into it. So the options are through the dummy, we have 12. Through I have 13. And through H, I have 15. So this is going to give us a 12. So then, yeah, going back up to this one, now I can do this node. So just be very careful. Don't try do the nodes in any order. If you don't have the information yet, you need to go back to a previous node and work with it. So using the dummy, I'll get a 12. Coming back through G, I get a 16. So this is going to be our 12, smallest number always. So then I can work here because there's only 1 coming back into it. It's going to be 12, take away 1, which gives us the 11. If I look at this node, there are 2 feeding back into it. I have the dummy, which will give me 12, and I have E that will give me 5. So that is 5. And then for this node here, I have 2 feeding back. I have 12 through the dummy, or I have 12 minus 4, which is 8 coming through F, and 8 is our correct answer. I then have 3 feeding in here. That is 11 take away 3, which is 8. I have 5 take away 5, which is 0, and I have 8 take away 2, which is 6. I pick the smallest, and I get 0. You should always get 0, 0 in this source node. So take your time, be careful, don't be afraid to change it up, maybe use different colors, and literally, like I've done, dot where the activities are coming in and out of the nodes, so it's very, very clear. Now we're going to look at some critical activities. Now, critical activities will only occur where the node has the same early and late time, but it doesn't mean it's definitely going to be critical. So the first activity I'm going to look at is B, because B ends with 5, 5, so this could be critical. So what I do is I say, okay, it starts at 0, it goes on for 5, and it ends at 5. So that is definitely critical. E is the next one that could be critical. So we start at 5, the duration of E is 7, and we end at 12. That is perfect. Okay, we're happy with that. The next two nodes that could be critical are H, starts at 12, lasts 4, ends at 19. That's not critical. 12 plus 4 is 16. 19, that is not critical. It has a float. So be very careful. H is not critical. Is I critical? Starts at 12, goes on for 5, ends at 18. No, 12 plus 5 is 17. It's not 18. I is not critical. Be very careful not to just assume that these are critical. So the next one that could be critical would be J. J starts at 12, goes on till 18, and has a duration of 6. Yeah, J is. So 12 plus 6 is 18. Then L starts at 18, lasts 1, and then 19. Yeah, L is critical. And then we have M could be critical, 19. Plus 2, the duration gives me 21. So the most common error we see on this is students assuming that just because an activity is between two nodes that have the same early and late time, that it's definitely critical. That is not true. You have to check the duration. Now, at this point, you might go, do we have a critical path? And we do, because here we have a dummy. So the dummy can be part of that path. So our path is B, E, J, L, N, because E and J are connected through that dummy. You don't need to have your dummy written in as part of your path. It's not a real activity. All it's telling us is that J is dependent on E. That is all that dummy is telling us. So part 3 asks, what is a critical path? So critical path is a continuous path from source to sink which joins only critical activities. Any delay in an activity on the critical path will result in a delay in the whole project. So our critical activities are those that have a 0 float, or you can think about it that will, if there is a delay, it'll delay the whole project. So if activity K takes 5 weeks instead of 3 weeks, what effect will this have on the critical path or paths and the time taken to complete the project? Explain your answer. So we need to go back here to our actual network and we're looking at K. So let's find where K is. So what we want to think about for K is, well, what is its float? What extra wiggle room does it have? So the float is going to be the latest finishing time minus the earliest start time minus duration, which gives 2 weeks. So because it has 2 weeks float, it's going to have no effect. Okay, so it's going to have no effect on the critical path. It's going to have no effect on the time. So it's not going to delay. But what will happen is if this goes to 5, then that 15 goes to 17. And then actually that becomes another critical activity. And then if we look at N will also become critical. So actually, if that were to happen, we will get a new critical path. So another critical path. So another critical path. So the other one is still there. So another critical path. And that path will be B, E, K, N. So 2 things that they're asking, what effect will it have on the critical path? So we'll get another critical path and the effect on the time, and there will be no effect on the time because of the float. So this is the float of K. This is question 9 from the 2023 Deferred Higher Level paper. The diagram below shows a scheduling network for a project to construct a stage for a music performance. The network provides some information about the relationships between the 13 activities that have been completed in the project. that have to be completed in the project. The edges of the network represent these activities and are labeled the letters A to M. The letters are used to label the edges should not be taken as representing the order in which the activities happen. The nodes of the activities represent events or points in time during the project. The source node is the time when the project begins, and the sink node is the time when the project ends. So we have our network here below, our activity network, and part 1 asks us to explain the significance of the edges represented by dotted lines. So these are dummy activities, so they're not real activities. They don't have any time attached, and they're included just to show dependencies. So for example, if we take a look here at this edge, what this edge is doing, it's saying that before we start H, we must have B done, but equally, we must also have C done because C is connected with that dummy. So that's what dummies are used for. So then part 2 asks us to complete the table below, listing for each activity the other activities on which it depends directly. That is, for each activity X, which is an element of A all the way to M, write the smallest possible list of activities which need to be completed before activity X can begin. Use the space below to show relevant supporting work if necessary. So this is called a dependency table. So a dependency table shows a list of all the activities for a project, and for each activity, the table includes a list of activities that must be done before that activity starts. So we talk about it being dependent. So when the table is completed, we're only putting in any immediately preceding activities, and that's really, really important, because if you say B depends on A and C depends on B, you're including A. There's no need to put A in again. So activities that don't have any previous activities that they depend on are going to get just a little dash to show that we're not leaving it blank, because then it's not really answered. We want to really show that we know that there is no dependencies. So when you're filling out this table, it's really important that you're working with your graph. So I've put a little graph up here. And we'll start with A, B, and C. So A, B, and C are at the source node, which means they have absolutely no dependencies. Then we have D. What I like to do to kind of see what's happening is I'm going to put a dot, a very clear red dot, where we're starting with D, so I can see what's feeding into that dot. So I can see that A is feeding in there, which means D is dependent on A. And actually E, which is coming out of that same node, is also dependent on A. So then if we move to F, which is, I'm going to keep with my red, so here's my F, feeding into that is just C, so it is dependent on C. So then G, so this is where things are going to get a little bit more interesting. So G has three activities feeding into it. It has E, it has B, and it has a dummy, and that dummy is feeding from C. So it has B, C, and E that must be done before G happens. Now, H and I go from the same node. So I'm going to fill in my H and I, because you see there's G we've just done. H and I come from the same node, so it's going to be the same answer. So it's going to be B, C, E here too, and we're going to have B, C, E here too. Okay. So then we have J. So my node where activity J starts is here. And feeding into it, we have two activities, which are D and G. And K is at the exact same node, so it's also going to have D and G. And then we have L, and it has three activities. It has K, H, and this dummy feeding in, but the dummy is coming from a node where both I and F feed into that. So we have F, we have I, we have H, and we have K. So there's a lot going on there, and it's very, very easy to miss one. If you have a dummy node, if you have a dummy activity, you go back to the node where that comes from and see what feeds into that. And then our final one is there's two activities feeding in there, and that is F and I. And that is our dependency table completed. What I would say about these, take your time. I like to kind of really figure what node am I at to start this activity and see what comes into it. Often just glancing at it alone can lead to you missing activities. Remember, we only need any activities that come directly into that node. Anything before that we've already captured. Okay, so we've already captured that in an earlier dependency. So part 3 then asks us to get the time in hours. It tells us that the time in hours to complete each of the activities is represented by the number in brackets. Calculate the early and the late time for each event. Complete the diagram below to show by writing the early time in the upper box and the late time in the lower box at the node representing each event. So we just have to be extra careful when we have dummies here. First, what we're going to do our forward pass. That means we're going to look at all of the early times, the upper boxes. If there are multiple possible early times, we always take the biggest. So we take the biggest early time. And then when we get to the end, we're going to go back and do the late times. So we always start our source node at 0. I'm constantly looking at what's feeding into each of these nodes. So here we have activity A, and that's all that's feeding in. So that means 3 is my only option here. So for this node here, we actually have 3 different activities feeding in. So I can't answer that node yet. I'm going to have to go back here. So this one just has C, which is fine. So that's going to be 5. So going back to my middle node, I have E, I have B, and I have a dummy coming from C, or coming from the node after C in. So my options are, I have 3 plus 4, I have 7 coming from E. I have 0 plus 2, I have 2 coming from B, and I have 5 coming from C. I want to pick the biggest, so that's going to get me a 7. So take care with those dummies. So then the next one I'm going to look at is this node here. There are 2 activities feeding in, both F and I. We're going to pick the biggest. So we have going from F, we have 9. Going with I, we have 7 plus 6, which is 13. 13 is bigger, so that's the one we're going to stick with. Then I'll move up here. It has 2 activities feeding in. So we have D, which will add 5 onto 3, which is 8, or G, which will add 2 onto 7, which is 9. So this is 9. And then let's move down here. I have 1, 2, 3 nodes feeding in. So if I go K, it'll give me 12. If I go H, it gives me 10. The dummy gives me 13. So the dummy is the one that we want to work with. So that's a 13. Great. And then we're on to our sync node, so our final node, and there is 3 options feeding in here. We have J, which will give 11. We have L that will give 15, and we have M that will give 16. 16 is the biggest. That's the one we stick with. The next thing we do is we remind ourselves that the sync node always has the same early and late time. So we put 16 there and we start working backwards. So we're going to work backwards to get the late times. If there's multiple options, we're always going to pick the smallest late time. So let's start with this middle one here. There is 1 activity that feeds out of it. So you're looking basically at it backwards. So we care about what's coming out of it. That was 16 take away 2, which is going to give us 14 there. Then if I come back here, there's 2 that are feeding out from that node. There was J and K, so I'm looking at the bottom numbers. So 16 minus 2, which is 14. 14 minus 3, which is 11. Remember, we're always picking the smallest one when it's a late time. So that's 11. Down here, I have 2 feeding out of it. So I have the dummy, which will have no time change, so it's just 14, and then 16 minus 3, which gives us 13. I'm going to pick the smaller, that is 13, and we can keep going. So let's go here next. So there's 1, 2, 3 feeding out of it. If I go down the root of G, it's going to be 9, H is 11, and I is 7. So we're going to pick the smallest of those 3 numbers, and the smallest is 7. Okay, now I'm going to work here. So there are 2 activities coming out of that node. There's a dummy, so that'll stick to 7, and then F, which is 9, so the smallest of those is 7, so I'm going to keep my 7 there. I then have 1, 2 coming out here. If I work with D, 11 minus 5 is 6. If I work with E, 7 minus 4 is 3. So there's a 3, and then finally my source node, which always should be 0, but we're just going to double check it. So option 1 is going with activity A, which will bring us back to 0, activity B, which will bring us a 5, and C, which will bring us a 2. The smallest of those numbers is a 0, and that is our completed activity network with our early and late times. What I like to do at this point, because it probably will be asked, but while we have a nice clear diagram, is to look at critical activities specifically, and then we'll see is there a critical path. So critical activities will only exist between nodes that have an early and late time the same. Now, it doesn't mean that they have to. Okay, it does not mean that they have to be critical, but we'll be able to check it. So the first one I'm going to look at is activity A. Activity A is critical because it has a start time of 0 and then duration of 3, and it finishes at 3. So that is 100% going to be critical. And the next one that's a possibility for critical would be B, because it goes to 7, 7. So 0, 2, 7, no, that's not going to work. That has extra time. So be careful. Just because it's between these 2 nodes does not make it automatically critical. What about E? So it starts at 3, goes on for 4, ends at 7. Yes, E is critical. So don't just look at the early late times and assume if they're the same that it's going to be critical. It can only be critical if they are there, but it doesn't guarantee it to be critical. So then the next one that we could have as critical would be I. So 7 plus 6 gives us 13. So that is critical. And then we have 13 plus 3 gives us 16. So that is critical. And there's no other activities between 2 nodes like that. So that looks like it's our only critical activities, A, E, I, M. And in terms of a path, that is itself a path. So if we need it for any of the next questions, we have it. It's a really quick thing to do, and especially when you're working with practice questions, it's a great thing to do from your graph. So part 4 asks us to write down the critical path. So we've already done the hard work on the diagram, and the critical path is AEIM. And then part 5 asks us to calculate the minimum time needed to complete the project, and the answer is 16 hours. This is just the time that comes from the sync node. So 2 lovely questions once you've done all your work on your activity network. Then says if D takes 7 hours instead of 5, what effect will this have on the critical path or paths and the time it takes to complete the project? So activity D currently takes 5 hours. So let's calculate the float for D. The float is going to be the latest end time minus the earliest start time minus the duration. Really, really important little formula, not to assume it's just 9 minus 11. It's 11 minus 3 minus 5, and that gives us 3. If you just did 11 minus 9, you'd have your 2. So there's an extra 3 hours. So that's okay. So there's no delay because it has it in the float. Would it then become critical? Well, an extra 2 hours, no, it's still going to have it's still going to have a float, so there is no effect on the critical path. So it's not like we're adding in a new one. So then if J takes 7 hours instead of 2 hours, what effect will this have on the critical path or paths and the time taken? So J then, we again want to look at the float. So J's float is going to be 16 minus 9 minus 2, which gives 5 hours. This is a 5 hours float. And that means it will have no delay, but it will now end up being more of a critical activity. So if we had 5 hours there, we then suddenly cannot delay it because it will delay the time. So we just have to be really, really careful to try and make sense of this. And the best way to kind of think about it is if we started on, let's say, started on hour 9, and now J is 7 hours, and this is still 16, we go backwards, and if we were to look at the two activities feeding into it, 11 was from K, but J now being 7 will give us a smaller time, so that's going to be 9 and 9. So that's going to change this up to being now a critical activity. If that, let me change it on the diagram. If this here is 9, we now have a new critical activity here at J, but equally we get one at G because G now is 7, starting at hour 7, goes on 2 hours and ends at 9. So we now have a new critical path. Okay. New critical path, which is going to be AEGJ. So questions like that can be really, really tricky. So take your time. I know I've been able to use my diagram maybe a little bit more, but don't be afraid to draw it out. Don't forget how these previous activities can also be brought into play, like G for this question. So this is question 9 from the 2023 higher level paper. The manager of a regional hospital decides to arrange for a refurbishment of one of the hospital wards. The diagram below shows the scheduling network for the project. The edges of the network represent the activities that have to be completed as part of the project and are labelled with the letters A to L. The duration in days of each activity is represented by the number in brackets. The unlabelled edges, shown with dashed lines, do not represent real activities, but they help explain the order in which the activities must happen. The letter used to label the edges should not be taken as representing the order in which the activities happen. The nodes of the network represent events or points in time during the project. The source node is the time when the project begins, and the sync node is when the project ends. Now, I think this is one of the trickier ones because we have a dummy there. Let me highlight it. So this one here, and that's kind of going what we would nearly consider backwards. We end up kind of going backwards a bit. So this is a great one to test, are you really looking at the arrows? Are you really making sense of what's going on? There's also 4 dummies, so a dummy to a dummy, which is really, really tricky. So this is one to really take your time with and try and make sense of. So part 1 is asking us to complete the dependency table, and we're trying to figure out what the activities depend on. Now, the first few are fine. So A, B, and C are all at the source node, so there is no dependencies. So then when I look at D, so let me get my red out. So here's D. There's only one activity feeding into that, and that is A. So D is dependent on A. That's the same node for E, so E is also dependent on A. F then, we're down here, and there's only one activity feeding into that, and that is C. So that first column, very straightforward, no major issues. Now let's take a look at G. Now, for G, it has 2 things. It has B and it has this dummy. But for the dummy is coming straight from C. So this G is dependent on both B and C. So at that node there, B and C. So then we move on to H. Okay, so H is dependent on G. That's definite. And F. And this dummy, so this dummy here, which is being fed by E. So there's E, there's G, and there's F, so we don't lose track. And also this dummy here, which you might then accidentally go back and say, well, that's B, but actually we're not going to put B down because B is already included in G. There's no need to go back there because that dummy is not adding anything for us here going into H. So we only have E, F, and G plugging in there. So just be really, really careful. Like I said, the dummies can really upset things. They can really throw you. But that dummy there, let me do it in a different color. This dummy here doesn't really add anything because all we have is back to a node where G is already coming out of, so we don't really have to worry about it. It's already caught up when we deal with G. So then our next one is I. So I is here. So we have a dummy feeding into it. We have E feeding into it. So E is definite. And then of the dummy, now we're going to say, well, B feeds into it. And in turn, C feeds into it because we don't have G or another activity that has already been told to be dependent on B and C. So now we have B, C, and E, which I is dependent on. So then J is at the exact same point, so that makes life a little bit easier. So it starts at the same node. And then if we look at K, where's K? Here we are. So K has just a dummy feeding into it. Into that dummy feeds F and feeds G and feeds another dummy. And into that dummy feeds that dummy that we didn't really care about before, and we're not going to care about it now. So we're going to have E, G, and F. So we'll put them in order, E, F, G, when it goes in. For the same reason, we're ignoring this because that dummy just takes B and C, which remember have already been included in G. So because we get back to this node where G has already started, we know that everything has already been considered feeding into G. So then last but not least, we have L. So L is here. It's nice and straightforward. We have two nodes feeding into it, and that is D and J. So probably one of the trickier questions we've seen to date with the dependency table because of the sheer number of dummies, the fact that there's 4, but also the fact that there's one kind of nearly going backwards as well and how the dependencies worked. So next we're being asked to calculate the early and late times for each event. Let's do our early time first. So remember, if there's multiple answers for the early time, we're always taking the biggest. So we started our source node. A only has one coming into it, one activity, so that's going to be 14. B actually has 2, so we can't do that yet. C has 1, which is 14, and now we can look at B. So B has the node after B. So that node has B feeding into it, which is 12, or the dummy, which is 14. We always take the bigger, so that is 14. So just be careful, that dummy can throw us, and I think the direction there was tough as well. So then this node here has 2 options. We can go from G, and that will be 17, or F, which is 18. Remember, we always want to pick the... Oh, and actually, apologies, there is a third one that is linked in this way. So I can't do this node yet. I'm going to have to pause. So then let's look at this node. We have 2 feeding into it. We have the dummies, that'll be 14, or E, which is 19. So that will give us 19. I can do this one, which is if I come from D, it's going to be 26. If I come from J, it's going to be 30. So 30 is the bigger option. Let's go back down to this one here. It was really hard to see this little a dummy one between these two when the box came in, so easy to miss. So our options are, we have the dummy, which is 19, we have G, which is 17, and we have F, which is 18. So actually our maximum here, the biggest of those values, is going to be 19. Here, this is just a dummy activity, so this is going to be 19. And then we're on to our sync node. So we have 1, 2, 3, 4 options. So L will give us 32, I will give us 30, H will give us 31, and K will give us 32. So we're going to go to the biggest, which is through K, and that is 32. And then our sync node has the same time for both early and late, and then we start working backwards. So there's only one activity coming out of this node, so this is going to get us back to just 30. Here we have 3 activities feeding back to it, so we can't do that one yet. Let's do this one. This is only one activity feeding back to it, which is 19. Here we have 2 activities. We have H and we have a dummy. The dummy will give us 19. H will give us 20. If there's more than one, we always pick the smallest. So this is going to be 19. So then let's go back to this one here. So I have a dummy, which is 19. I have I, which will give us 21. And then I have 30, which is 19, or I have J, which is 19 as well. So the smallest value of those is going to be 19, and it could go either way. So next, let's look here. I have 2 activities coming out of that node. If I were to go down with activity D, that would leave us with 18. E is going to be 14. So we're going to go with the smaller of those, which is 14. And then we could do this one and this one. So we have a dummy, so that's 19, or 19 minus 3, which is 16. Smallest of those is 16. I'm going to do this node next. So there's 2 that feed out of it. So the dummy will give me 16. F will give us 15. So that's going to give us the smaller answer there, which is 15. And finally, 3 activities feeding out of the source node. A, 14 minus 14 is 0. B, 16 minus 12 is 4. And C, 15 minus 14 is 1. So we're going to go with the smallest, which is 0. So we have that now fully completed. So the dummies do cause just a little bit more work for us and just a little bit more thinking. So just as always, I'm going to look at my critical activities, and critical path. Part 3 does ask us for the critical path. So remember, our critical paths only exist between nodes where the early and late times are the same. So it could be A, it's definitely not B, and it's definitely not C. So it could be A. So starts at 0 and then adds 14 and gets us to 14. Yeah, so that one is critical. So there's a critical activity right there. We then have D, which is 14 plus 12 and 30. No. And this is where students can be like, no, but that's definitely critical, because it starts at a node that early late times and it ends at a node where early and late times are the same. But no, that's not necessarily true. You still have to check the duration. So 14 plus our 12 gives us 26 and not 30. What about E? So 14 plus 5 gives us 19. Yes, so that one is good. And then J is 19 plus 11 gives us 30. Yeah, that is also good. We have a few other ones that could be. So 19 plus 11 is 32, and it's like, nope, okay. L could be, so 30 plus 2, 32. Yeah, so L is. What other ones? So H could be 19 plus 12 gives 32. No. But what about K? 19 plus 13? Yes. So K is. Okay, so K looks a little bit like stranded over there on its own, but actually there is a pathway because the two dummy nodes, or the two dummy activities here, can help it to create a path. So there's actually two paths here. So the two paths are A, E, J, L, and then the second one is still A, E, but then it gets us K there at the end because of the two dummy activities connecting them together. So just be careful with that. If you feel like there's an activity kind of critical, but somewhere random, not connected to anything, is there dummies that can connect it back to some other critical activities? So the next part of this question tells us a cascade chart or Gantt chart is a type of bar chart which may be used to represent the project schedule. The duration of each activity is represented by the width of the horizontal bar for the activity and the time on the horizontal axis. With the time on the horizontal axis. The float time for an activity is represented by a rectangle drawn using dotted lines to the right of the bar for the activity. The top row of the cascade chart is used for the critical path. Draw a cascade chart or similar bar chart to represent the schedule for this project. So let's talk a little bit about what a Gantt chart or a cascade chart is. So here's an example of one. So we're looking at activities and we're looking at how they fit together. So the deeper blue is just the activity themselves, and then the lighter one with the dotted line, that is showing us the float. So the flexibility it has. Think of it as like that activity A. So if we look at activity A here, so activity A could slide all the way to here without any delay. C could slide to there, D could slide to there, and E could slide to there, and so on. And when I say delay, I mean delay in the overall time for the project. So it won't delay that critical path. The critical path is shown up here at the top, and notice that there's no float. There is no wiggle room for this particular critical path. Well, there's no float for a critical path ever. So for these particular activities, there is no float, is what makes them critical. So let's draw this cascade chart. So remember we were told in this question that the top row of the cascade chart is used for the critical path. So we're going to put that in first. I'm going to work from my activity network, which I think is a more efficient way to do it. If you're really struggling with this, if you're finding it difficult, another option is to literally calculate the float for each of the activities. Obviously ignore the critical activities because you know their float is 0, but that will help you get a better sense of maybe where that flexibility is if you're struggling to see it from your activity network. So I'm going to start with the path AEJL. So A starts at 0, has a duration of 14. So it looks like this. So it's a rectangle going from 0 to 14. And then E starts at 14, lasts 5, so ends at 19. J starts at 19, lasts 11 and goes till 30. And L starts at 30 and then goes on to 32. There is also a path AEK. I won't redraw AE, but I'll just put K directly underneath. It starts at 19 and it goes to 32. So I know the numbers here can be maybe a little bit tricky. If you look where the 34 is, what that is saying is at the end of that box it's 34. So like where this is, that is 19 because that 20 is telling us at the end of that box it's 20. So just be careful if you're thinking those numbers look a bit weird. So the next activity I'm going to do is B. So B starts at 0. It has a duration of 12, but it has a float. So we have to look at this number here at the bottom, so the 16. So I start at 0 and I go a duration of 12, but it can go up to 16. So how that's going to look is we're drawing our box for B, which is starting at 0, goes on 12. That's fine. But it has an additional little bit all the way up to 16, which we put in with dotted lines. And again, they told us this. dotted lines to the right of the bar. Now, technically, for these kind of charts, they could go to the left, but the question has said put them to the right, so we're going to put them to the right. So that's B done. If you want to kind of tick off your activities as you've done them, it'll help you keep track. So the next one I'm going to do is C. So C starts at 0, lasts 14, and it can finish as late as 15, meaning we get C plus a little bit extra to bring it up there to 15. So then we have D. D starts at 14, lasts 12, and can go up to 30. So in terms of what that looks like, let's start at 14 and draw a rectangle that is of length 12. That will bring us up to 28. And then that leaves us 2 boxes to bring us up to 30. Okay, so we just get that little bit extra there. So it's absolutely fine to use your activity network here. Just use it sensibly. So it's going to bring it up to 30. Next we have D, E, F. F is starting here at 14. It goes on for 4 and then 4 days, and then ends at 19. So there is a day's floating there. So 14, duration 4, and then we'll have 1 extra piece there. And that's F. And G starts at 14. Starts at 14 and lasts 3. That'll bring it up to 17, but we then have that extra flexibility until day 19. So there's G with its duration of 3, starting at 14, and then so we're going to bring this up to 19. And so then that's G. So H and I, there's no rule you have to have every box or every activity on a different line. So I'm going to fit in the others where I can. I starts at 11. No, sorry. I starts at 19, has a duration of 11, and that will bring us up to 30, and then it is allowed up to 32. So what that looks like is, sorry, H. So sorry, H starts at 19, has a duration of 12. So they're starting at 19, duration of 12. 19 plus 12 gives us 31. So it gives us 1 extra piece of our float. And then I is going to be 19 plus 11, which gives us 30, and then a little float of 2. So this is our completed Cascade chart. So the question then says, the hospital manager visits the project on day 18 to check the progress of the work, which is on schedule. Write down the activities which may be happening, okay? May be happening. They don't have to be happening. They may be happening. So here is day 18. I've put it right in the middle of the box. So here are the things. So E is definitely happening. D may be happening. So we have a little bit of a float here for D. So what we need to think about is, could D slide over enough that it hasn't started yet? And we have our float here of 4. So D in theory could slide over 4 and then not have started yet. So D may be happening. Okay, so just really be careful about that. So D may be happening. F could slide, but it will have to be happening. And G may be happening. But the question asks which activities may be happening. Well, E and F, D, and G. So when they say may, it includes all of them. If they say must, it would only be E and F. So anytime you look at these questions, it really would be worthwhile to think in terms of what may be happening, so might or might not, and which ones are definitely happening. So this is question 2 from the SEC sample higher level paper. The diagram below shows the scheduling network for a project to manufacture a new chemical compound. The network provides some information about the relationship between the 12 activities that have to be completed as part of the project. The edges of the network represent these activities and are labeled with the letters A to L. The unlabeled edges, shown with dashed lines, do not represent real activities, but they help explain the order in which which the activities must happen. The letter used to label the edges should not be taken as representing the order in which the activities happen. The nodes of the activities represent events or points in time during the project. The source node is the time when the project begins, and the sync node is the time when the project ends. So complete the table on the next page, listing for each activity the other activities on which it depends directly. That is, for each activity X, element of C, D, E, and so on, write the smallest possible list of other activities which need to be completed before activity X can begin. Activities A and B do not depend on any prior activities, so the list is empty for these activities as shown. So they're given to us with dashes. So what we're going to do is we're going to start with C. So C starts here, and there's only one activity feeding into that, and that is A. E is at the same point, so I'm going to fill that in there as well. So then let's look at D. D is only one thing feeding into that node, and that is B. And that is the same for F as well. So then let's take a look at G. Let me get rid of all these. So at G, so for G, I have F feeding into it, and that is it. So G is F. And then let's take a look at H. So H has C feeding into it, which is fun. So C feeding into it. It also then has this dummy, where what's feeding into the dummy is E, and then the dummy has a dummy feeding into it, which is F. So we actually have C, E, and F, which H is dependent on. So then if we move on to I has E, I has a dummy, which F is feeding into that dummy. And that is it. So we have E and F. And then we have J, which has D feeding into it, and a dummy. That dummy has F feeding into it. So it's D and F. And then we're at K. K has J and G feeding into it. And the dummy's not feeding into it, it's feeding out of it. So that is G and J. And then finally, for L, we have H, we have I, we have a dummy, and into that dummy feeds J and feeds G. So we have G, H, I, and J. So it is 4 things feeding into it there at L. So for each of the statements in part II and III below, state whether you agree or disagree with the statement. Activity D must be completed before G. So let's look at D. So does D have to be completed before G? And the answer is no. There's no dependency there. G does not have a dependency. So I would disagree, because G does not have a dependency on D. There's no dependency there. And then it asks about activity E must be completed before H. So here's E. Go back to my highlighter. There's E and there's H. That one is true because we have this dummy connecting them. So this one I agree with. H is dependent on activity E. So you can see that dependency there. So it tells us that the time and days to complete each of the activities A to L is given on the table below and has also been included in the network redrawn on the page. So there's our table. So we don't have to worry too much about the table. It's all shown on the diagram. So let's focus on that diagram. Part 4 asks us to calculate the early time and late times for each event. So let's start with our early time. So we start with our source node 0. We then get a 5 and a 3 for A and B. So then the only one I can do next is this node here. It has F feeding into it, which is 5. Once I've that done, I can look at this node. This node has 2 things feeding into it. We have E, which will give us 9 or 5. We always want to pick the bigger one, so that's going to leave us with our 9. So then I can look at this node here with 2 feeding into it. I have D feeding into it, which will give us 12 or 5. We want the bigger one. So this one here is going to be 12. So then we have 2 nodes feeding in here. We have G, which is going to give us 13, or J, which is going to give us 14, and we pick the bigger one. This node here has C, which will give us 11 or 9, and we're going to pick the bigger one. So that is 11. And then here we have 2. So we have H, which will give us 15, or I, which will give us 20. So 20 is the bigger one. That's the one we're going to work with. Oh, sorry, and I actually missed one here. So here I have H, I have I, and I have a dummy. So I have H, which will give me 15, I, which will give me 20, or a dummy that'll give me 14. So that is still going to be 20. And then our last node has 2 feeding in here. So L will give me 25, and K will give me 21. So 25 is the larger number. So that is our time for the sync node. We then fill that in here and we start working backwards. I'll change up my color so we can see 25. So then going backwards, there is 1 thing feeding out of here. So that's going to get us 20. Here we have 2 activities feeding out of it, which is either going to be my dummy, which is 20, or K, which is going to bring us back to 18. Now I always pick the smallest when I'm dealing with late times, so that's going to be my 18. Next I have here, it's going to bring 2 back, which gives us 16. Then here I have 1, 2, 3, can't do this one yet. Let's pause it. Let's go for here. So we have 20 take away 4, which gives us 16. This node here has 2 feeding out of it. So it's either going to be the dummy will give us 16, or I will give us 9. We want the smallest one, so that's going to be 9. Now I can do this node. I have 9, or I have from G, I have 10, or the other dummy, I have 16. So that's going to give me 9. And then we have, coming back here, F, which will give us 7, or D, which will give us 7. So it's much for muchness, they're the same. So 7. Here we get C will give us 10. E will give us 5, so we'll pick the smaller one, which is 5. And then we have A will give us 0, or B will give us 4, so we'll get our 0. So that's our early times. Now we're going to look at our critical activities. So A is a critical activity because it starts at 0, lasts for 5, and ends at 5. E is critical because it starts at 5, lasts for 4, and ends at 9. I is critical because it starts at 9, it lasts 11, and ends at 20. And then our last one is L because it starts at 20, it lasts for 5, and then it goes on until 25. So we have no other critical activities there. So then part 5 asks us for our critical path, and that's going to be A, E, I, L from the diagram below. And write down the minimum time and days needed for the project, and that's very straightforward, and that is 25 days. and then select any one non-critical activity on the network and calculate its float in days. So we're actually going to do all of them just so we can see. The calculation for float is the latest finishing time minus the earliest start time minus duration. So just be careful not to assume it's just these two numbers taken away. There is more to float than that. So this is 5 minus 0 minus 5, which gives a float of 0, and that's why it's critical. B is 7 minus 0 minus 3, which gives a float of 4. C is, where is C? C is 16 minus 5 minus 6, which gives us a float of 5. D is 16 minus 3 minus 9, which gives us 4. E is critical, so 9 minus 5 minus 4, which is 0. F is 9 minus 3 minus 2, which is 4. G is 18 minus 5 minus 8, which is 5. H is 20 minus 11 minus 4, which is 5. I is critical, so 20 minus 9 minus 11, which is 0. J is 18 minus 12 minus 2, which is 4. And then K is 25 minus 14 minus 7, which gives us 4. And L is critical, so we should also get a 0. Okay, so there are all the floats calculated for all the activities. Make sure you're very, very clear on how to do that and not to accidentally assume that it's just the early time minus late time for the finishing, because that sometimes works, but it won't always. So part 8, the last part of this question, tells us the project is due to begin on the morning of July 1st. The key worker needed to carry out activity G will be away on holidays when the project begins. What's the latest date on which this worker could return to work without necessarily causing the project to be delayed? Okay, so we started on day 0, which in terms of dates means July 1st. So activity G should start. So should start on day 5, which is July 6th. But it has a float. So let's take a look at G down here. But it has a float. So the float of G is 18 minus 5 minus 8, which is 5 days. So it can be delayed for 5 days. So it can start 5 days later. That's what the float tells us. So that's going to be July 11th. So our answer there is the latest it can start is July 11th. So this is additional example 1, which is looking at some things that have yet to be asked on the Leaving Certificate paper up to June 2024. So project is modelled by the activity network shown on the left. The activities are represented by the arcs. The number in brackets on each arc gives the time in days to complete the corresponding activity. Each activity requires 1 worker. The project is to be completed in the shortest possible time. So we have 4 questions. We're told to calculate the early times and late times for each event, and there's going to be a diagram which I'll put up on the next screen, and then we're going to state the critical activities. We're going to draw a cascade chart, and we're going to use the cascade chart to determine the minimum number of workers needed to complete the project in the shortest amount of time. So here is our early and late times. So let's work through this piece by piece. So let's do the early times first. Remember, when we're getting our early times, we're always looking for the biggest early time. So here at this node, there's only a feeding in, that is 7. Here it's going to be 5. Here there are 2 different activities feeding through. We have 7 coming from the dummy and 6 coming from B. So we're going to pick the bigger of that, which is 7. We then then have here, which has two options. We can go with D, which is 16, or E, which is 12. We're going to pick the bigger of them, which is 16. Oh, I'm sorry, and we actually have one there. So we need to hold off doing that for a second. So here we have F, which is 7, so that's going to be 14, and G, which is 8, which is 13, so the bigger of that is 14. So now we can go back to this node here. So we have a dummy, which will give us 14, E, which will give us 12, and D, which will give us 16. So the biggest there is 16. So then our next node here just has one feeding in, that is 5. Here we have 3 nodes feeding in, so we just have to wait for a second. So we'll do this one next. So J, sorry, that's not 5. So 5 plus 16, so that's our 21. So the next one is J, so that is 16 plus 19, which is 25, or 14 and 5, which is 19. So we're going to go with that 25. And now we're working with this node here. So we have a dummy, so that's 25, or I, which is 16, plus 7, which gives us our 23. So that's going to be our 25. And then last, our sync node, which is going to have either L, which is 26, or M, which is 31, or N, which is 35. So the biggest of that is 35. So now let's do the late times. Remember, with the late times, we're always looking for the smallest late time. So we put our 35 in here to begin with. Let's go back to here. So this has only one thing coming out of it, one activity, and it's 35 minus 6, which is 29. Here we have two activities coming out of it. We have a dummy, which is 29, or L, which will give us 30. We're going to pick the smaller of them, so that's 29. For the next node down, I lost, that was 25. For the last node down the bottom here, there's 2 coming out of it. There's a dummy, which will bring us back 29, or N, which will bring us back 25. We always pick the smaller of them, so that is our 25. We then have 3 activities that come out of this node. If we look at H, it's going to give us 24. If we look at I, it's going to give us 22. And J is going to give us 16. So the smallest of those is 16. This node has 2 coming out of it, a dummy, which will be 16, and K, which will be 20. So we'll pick the smaller of those, which is 16. We can then go to here. There's 2 activities coming out of it. So E is 5, so that'll give us 11. F is 7, which will give us 9. So we have our 9 here. This node here, we have a dummy coming back. That's going to be 9. Or D is going to give us 7. So the smallest of those 2 are 7. And then here, a nice straightforward one is just 16 minus 8, which is 8. And then let's double check everything works back to our source node. A, 7 minus 7 is 0. B, 9 minus 6 is 3. And C is 8 minus 5 is 3. So 0 is our smallest amount. So this is our completed early and late times for this activity network. So part 2 then asks us to state the critical activity. So let's look at it. Any activity between nodes where the early and late time is the same, we need to check. So A starts at 0 and goes on for 7, ends at 7. That is critical. D starts at 7, lasts 9, gets to 16. That is critical. H is not critical because 21, 29. I is definitely not critical. J could be critical. So starts at 16, goes on for 9, brings us to 25. Yeah. And then N is critical. There's no other critical activity. So that's our critical paths. The activities are A, D, J, and N. So you don't have to check any activities that are between nodes that don't have the same early and late time because they're definitely not critical. But just because the activity is between nodes that have the same early and late time does not automatically make them critical. So just be careful. So let's draw a Cascade or Gantt chart for this project. So here is our Here's our early and late times and our full activity network, and just highlighting again J and N, that's our critical path. So the first thing we always do is get our critical path laid up. The next thing we're going to do, I'm going to put B in, and it has its float. C, D is already there, so we go E. E starts at 7, lasts for 5, but doesn't have to end until 16. Then we have F, G, H, I, J is already there, K, L, M, and then N is already there. So part 5 then asks us to use our cascade chart to determine the minimum number of workers needed to complete the project in the shortest time possible. So we're going to introduce an idea called theoretical minimum number of workers, or also known as lower bound. So what we're basically trying to do is to estimate the minimum number of workers that we could need. So this is like a theoretical minimum. You may not get away with only using this number. You may have to have more, but it is a lower bound. It's as low as we can possibly go with the number of workers. So if we're trying to do this, and you'll see it's a bit of a trial and error situation in a second, what we really want to make sure we're starting with at least this lower bound or theoretical minimum number of workers. So the formula is the total amount of hours, so adding all the durations together, and then we divide that by the critical time. So that's the time in your sync node. It's known as our critical time, the time it takes to complete the critical path. So here is our Gantt chart, or our cascade chart, and we're going to first work out the lower bound or theoretical minimum number of workers needed. So we're going to add all of our durations. So that's 7 plus 6 plus 5 plus 9 plus 5 plus 7 plus 8 plus 5 plus 7 plus 9 plus 5 plus 5 plus 6 plus 10. So all the durations. That gives us 94. Divided by the critical time, which is 35, and that gives us 2.69, so we round that up to 3. So the absolute minimum number we could, in theory, use will be 3, but let's see if that actually works out, because it really depends on the activities, what they're dependent on, and so much else. So this is theoretical. So what I'm going to do is I'm going to start with my critical path and assign that to a worker. So that is my first worker. Then I just work with each of my activities and try and assign activities to each worker one by one. Just some things to remember when we're doing this. Make sure that you take we're going to assume that each of our activities starts and ends on time. So we're not going to worry about that grey part. We're not going to worry about our float piece. We're just going to work with the early and late. We're only going to work with the actual duration piece. So I'm going to assign B to a worker. And then I'm going to find an activity that they could do when B finishes, which would be E. Now, the reason I can do that is because even though technically B has still got a bit of a grey part there, there's a bit of float, we're assuming it finishes on time. And then once E is done, I could give it K, and once K is done, I could give it M. So that is worker 3. And that's not the only way it can be done. I'm just trying to figure out how many workers I need, so it doesn't matter. Once I assign them things in a very sensible, logical way, that is absolutely fine. My next worker will be doing C first, and then could do G, then could do H, and then could do L. Why I'm choosing, why did I choose H over I, even though they're the same start time? I'm going to work with the shortest durations first, so I can fill out to the end. So that's my 3 workers, but I still have activities need to be done, so I do need a fourth. So a fourth one to do F and I. So the actual minimum number of workers needed to get this all completed on time is 4. So additional example 2 explores some ideas from this section that have yet to be tested in the Leaving Certificate exam up to the exam in 2024. So the network to the left show the activities that need to be undertaken by a company to complete a project. Each activity is represented by an arc, and the duration in days is shown in brackets. Each activity requires exactly 1 worker. The early event times and late event times are shown at each node. Given the total float on activity D is 1 day, find the values of W, X, Y, and Z. So we have some unknowns. So this is, rather than filling out the whole thing, they've given us a partially completed activity network with early and late times with 4 unknowns. So let's start with using the float that they gave us for D. So D, the float is going to be 17 minus 5 minus W. That is the latest finishing time minus the earliest starting time minus the duration, and that should give us 1. And then that gives us W equals 11. So then in order to find X, the way we're going to work it is we're going to look at we're going to look at activity I. So we're starting I at 9 and it's going on for 12. That will give us 21. The other option here is J, so 3 plus 10, which will give us 13. For the early time, we always pick the biggest, therefore X is equal to 21. Our next one we're going to look at is Y. So in order to find Y, it's a late time, so we're going to work backwards. So there's 2 ways to work back into this node. So there's M and there's the dummy. So from the dummy, it'll be just 17. From M, it's going to be 30. Take away the duration, which is 6, which gives us 24. We always pick the smaller of the late times, which means we're picking Y as 17. And finally, looking at Z, again, another late time, there's 2 activities feeding out of that node. So that's J is 10 and F is 5. Looking at J is 10, we have 22 minus 10, which will give us 12. Looking at F, it will be 9 minus 5, which gives us 4. Again, it's a late time, so choosing the smallest late time is going to give us 4. So here is the updated activity network with all the unknowns filled in. Part 2 then asks us to draw a Cascade or Gantt chart for the project, and then part 3 says use your Cascade chart to determine the minimum number of workers needed to complete the project in the shortest time possible. So to draw the Gantt chart, what we're going to start with is our critical path. So let's take a look at our activity network and figure out our critical path. So we have some critical activities. So A is critical, starts at 0, goes on for 5, and it finishes at 5. E is another critical path. We then have G is not, H is, so 9 plus 8 gives us 17. I is not, and then we have L, which is not. We have K, which is, and then we can connect these dummies in here, which will give us a critical path. There's no other activities that could be critical. So we're going to fill in that critical path first. We have A, E, H, and K, and that's our critical path. Then for the other activities, B starts at 0, it goes for a duration of 7, and then it has the additional run until 9, so it has that little extra float. C then starts at 0, goes on for 3, and then it can go on till 4. So remember, we're always looking at the latest finishing time to figure out our extra bit of flexibility here in these charts. For D, it starts at 5, it goes on for 11, that would bring us up to 16, so it has an extra 1 there for flexibility. We then have E is already in there, so we'll look at F. F starts at 3 and it goes on for 5. And then there is an extra 3 and 5 is 8, so there's an extra 1 there to bring us up to 9. G starts at 9 and it goes on for 7, and then 9 plus 7, 16, it has an extra 1 there to bring us up to our 17. So E, F, G, H is done. I starts at 9 and goes on for 12. That will bring us up to 21, and then there's an extra 1 for 22. J is then starts at 3, goes on for 10, that's 13, and then it's quite a large float or flexibility piece here because 3 plus 10 is 13, and it goes all the way up to 22, which is an extra 9. And then K is already there, And then we have L, I'm just going to slot it in where I can. Starts at 17, lasts 5, which will give us 22, and then it has 8 then extra float to play with. And then M, which starts at 17 and goes on for 6, that brings us up to 23, and then that has an extra 7. And then the only one LM ends. N starts at 21. And 21 goes on for 8, so that's 29, and has 1 extra there for us. And this is our completed cascade chart. So then use the cascade chart to determine the minimum number of workers needed to complete the project in the shortest possible time. So the first thing I'm going to do is I'm going to calculate that theoretical minimum number of workers, that lower bound, and I just add all my times together, all the durations together. That's 104, and then I divide it by my critical time, which is 30, and that gives me 3.47. So 4 is the absolute minimum. So it may not be 4, there may be more, but I cannot get lower than 4. So what I'm going to do is I'm going to get one worker to do the critical path. So that is one worker just completed. So the second worker will do B. Remember, when we're picking tasks or activities for our workers, we ignore that float. We assume that everything starts and finishes on time. So if they do B, the next thing they could do would be maybe G, and then after G they could do M, and then there's nothing else for that worker to do. So we're at 2 workers. So third worker, I'll start them off with C, then they could do D, then they could do L, and there's nothing else that they could do, unfortunately, the way the timing is. Then we'll have one worker who does F, they could do I, and they could do nothing else, unfortunately. Well, they maybe could do N, but we'll need another worker for J and N will have to be done. So the pink worker could have done N, but it wouldn't have changed the need for another worker. So looking at that colours, we have the red, the green, the blue, the pink, and the orange. That means they will need a minimum of 5 workers to complete on time. So just be really, really careful with that theoretical minimum or that lower bound. It is not actually telling us anything specific. It's telling us in theory that 4 will be needed. So it definitely won't go lower than 4, but it could be higher, like in this case. So it's decided that the company may use up to 36 days to complete the project. Construct a scheduling diagram to show how the project can be completed within 36 days using as few workers as possible. So it is decided that the company may use up to 36 days to complete the project. Construct a scheduling diagram to show how the project can be completed within 36 days using as few workers as possible. So I have our cascade chart up there on the right, and I have our activity network down there on the bottom. So some things you need to keep in mind is what order should the activities be done in. So I'm going to group my activities into a few different groups to kind of make sure I don't accidentally schedule to do something that can't be done yet. So A, B, and C don't have any dependencies, so they're fine. We can work with those. We then have E, F, and D. Now they're all fine to do once A, B, and C are done. The reason I put them in order E, F, D is because I put them in order of the duration, with smallest first, so ascending order. After D and F are done, then we have G, H, I, and J. So that will be G, H, J, I. And then we have L, M, N, and K. So the first thing you want to do in a case like this, I'm going to start with my critical path. So our critical path, A, E, H, K. And that will give me 30, and I want one more activity then to bring me up to 36. So this is going to be worker 1. So there's that is also 6. So I'm just going to cross these off as I use them in here. So H, K, and M. So it doesn't matter. Could we do M and then K? No, so K, well, yeah, we could do M and then K. Order there doesn't matter. So just be clear, this is not the only solution. This is just a solution. So now I'm going to work with a second worker. And for the second worker, I'm going to start them off with B. because that has to be done kind of along the same time as A. And then I'll probably need a third worker at least, and I'm going to put C in there. So that gets rid of my first group. So then I need to think about, okay, so what activity is next? So what about D? So D is quite long, so I'm going to put D with C. So D, where is D? Can start at day 5. So I'm not going to wait for B to be done because that's going to waste a bit of time. So instead I'm going to slot it in here with C. So remember, just like when we were figuring out the minimum number of workers, we're ignoring any floats. We're assuming that everything starts and ends on time. So now that D is done, I'm going to put F in there, and that's 5. Looking at F, this is what the diagram with us, it can start at day 3. So actually F can pop in there. So my next one then is G. So G can start at day 9. So yeah, so G is fine to start there. So it's a little bit later. So bear that in mind, that we're not just looking at times, we're looking at dependencies as well. So G is used. And then after D is done, we can do J or I. I'm going to do I because it's longer here for C. And I, if I can find it on the diagram, I is going to start at 9 as well. And J could have started at 3. So I could have put J in there. I'm just thinking in terms of fitting more in, because now I can fit my J here. So J and I are in. And now I have to think about, well, what fits best where? So N can fit there and L can fit there. So it's really about making them fit. So if I put J, oh, let me try that again. So if I put J down here and had 10, then I have, am I wasting a little bit of space? Because I'm trying to make this get to as close as 36 as possible. And you can see I have a few gaps that I literally can't help. So the first, I have 2 days here and I have 2 days here. So I have like 4 days I can play with. So if I put J there, yeah, I probably could be okay, and put I above, that would still work. We can mix it around. It's a lot of just thinking about this logically and a bit of common sense. But do remember, this is not the only solution. So I'm going to do the same thing again, but I'm going to go in a different order, and I'm just going to show you like some ways you can kind of figure out orders. So the first thing I'm going to do on my activity network is I'm going to try and find a path that is 36 that's not the critical path. So I can add A, I can add E, so far it is the critical path. I could do G, and then I, and then N. So actually path isn't really the right thing for me to say. It's really a set of activities which I can put down that will take 36, because I want to, for my first worker, use them really, really efficiently. So I've now figured out, just through looking at my graph and working with my activity network, that I can assign here these activities to worker 1 without issue. You could in theory swap G and I. Doesn't matter because they both start at 9, so they're both ready to start then, but that gets us our first worker out of the way. So I'm just going to cross off our activities so I can keep track of them. A, E, G, I, and N. So then the next worker I'm going to assign B, and the worker after that I'm going to assign C. And then it's about figuring out the best way to kind of move forward. So here what I'm going to do, I'm going to actually assign F to worker 3. So then there is no delay, because F, remember, can start at 3. So I'm going to give F straight away from that little bucket I have. So remember, like, this is one set, this is another set, and now I'm going to assign D. So I'm going to maybe assign these in a little bit more structured order. So I'm going to assign D then here. So D is fine to start because it starts at 5, that's at 7, so not an issue. So now D is done. So the next one I can assign is H, and it takes 8, but just be careful, it can't start till 9. So this has to have a little bit of a gap, okay? So just be careful with that. So H, and then I want to assign J, so I'm going to assign J there. That's fine because J can, in theory, start at day 3, so that's very, very late. So it could go with either of them. The reason I'm kind of picking that is I'm giving K. So where have I got? So I have J, I have L, M, and N, L, M, and K left. So I'm going to give K here. Again, just watch your timing. So that starts at 17. So I just need to push that forward a little bit. And then after K, I have, where am I at? I'm at 30. So I'm going to, no, I'm at 31. So I want to put in L. That's the only one that'll fit. And then I can go to M. So again, just double check you're not causing issue by starting it sooner than it can be started. So again, that is not the only 2 solutions. A bit of practice on this will make a big difference to you. It is a tricky style of question, but if it does come up, it is only a part, and bear that in mind.